Welcome back, everybody. Today we're going to talk about parallel and perpendicular lines. Parallel lines always have the same slope. These lines will never intersect. Let's say we have y equals x plus 1, and we have y equals x minus 2. And what we're going to do is we're going to construct a table of values for x, plug them into the equation, and that'll generate values for y. Then we're going to go ahead and graph both equations onto the graph. So here's our first table. We have x and y. Let's choose values like -1, 0, and 1. Plugging -1 into the first equation, we're going to get -1 plus 1, which is just 0. 0 for x is going to give us 0 plus 1, which is just 1. And then 1 for x is going to give us 2. Now let's make another table for our second equation. Let's choose the same x values. -1 for x in the second equation is going to give us -1 minus 2. Let me tilt the camera here a little bit. It's going to give us -3. And we have 0. 0 for x minus 2 is going to give us -2. And we have 1. 1 for x is going to give us 1 minus 2, which is just -1. Now if we go ahead and plug in those, graph these equations. Let's mark off some increments here. Let's say 1, 2, and 3 on each side. 1, 2, and 3. We have 1, 2, and 3. So I'm gonna graph the first equation in red. We have -1 and 0, which is just here, -1 and 0. And we have 0 and 1, which is just 1 unit up from the origin. And we have 1 and 2. And it's just 1 unit to the right, and then 2 units up. And if we connect those dots, we'll have our first line. Now graphing our second line, we have -1 and -3, which is -1, 1 unit to the left, and then 3 units down. And we have 0 and -2, which is just 2 units down from the origin. And we have 1 and -1. 1 unit to the right, and then 1 unit down. And that's our second line. Notice how the lines behave exactly the same. They're different in terms of position on the plane, but they behave exactly the same because they have the same slope. And we can confidently say that they're parallel. Now moving on to perpendicular lines. Perpendicular lines, on the other hand, intersect at a 90-degree angle. So let's say we have our plane here. Let's say you have a line, a vertical line, going through here. And then you have another horizontal line going through here. Notice how both lines intersect exactly at a 90-degree angle. When you see this, you can say that the lines are perpendicular. Another way you can determine whether or not these lines are perpendicular is by looking at their slopes. Let's say I have an equation, y equals x plus 1. Then you have another line, which is y equals, let's say y equals 2x plus 1. And you have another line, which is y equals negative half x minus 2. Like I said, another way you can determine whether or not lines are perpendicular to each other is by looking at their slopes. If the product of their slopes is equal to -1, then you can confidently say that the lines are perpendicular. So the slope in the first equation is 2, and in the second equation is -1/2. If you go ahead and multiply those, you'll notice that the product here is -1. If the product of their slopes is any number but -1, then you can confidently say that the lines are not perpendicular to each other. Now let's look at an example. We're asked to find the slope-intercept form of the equation of the lines that pass through the point 2 and -1, and are parallel and perpendicular to the line 2x minus 3y equals 5. Now we can begin by writing out the equation in slope-intercept form. So we have 2x minus 3y equals 5. So what I'm trying to do is just keep the y term on one side and everything else on the other side. So we can begin by subtracting 2x on each side. We'll get -3y equals 5 minus 2x. Then we can divide each term by -3. And that's going to give us y equals -5/3 plus 2/3x. You can see that this equation has a slope of 2/3. Now, any parallel line to the given line must also have the slope of 2/3. So the line going through the point 2 and -1 that is parallel to the given line has the following equation. I'm just going to write this line up here. So we have 2x minus 3y equals 5. And then I'll just keep this point right there. Now using the point slope form, which is y minus y1 is equal to m x minus x1. If we use this slope and we use those points, we're going to get y minus y1, which is -1, is equal to the slope 2/3 x minus x1, which is 2. We can go ahead and simplify. Y plus 1 is equal to 2/3 x minus 4/3. We can simplify even further. Y equals 2/3 x minus 4/3 minus 1. And we can combine these two terms. Minus 1 is just simply minus 3/3. And if you combine those terms, we're going to get negative 7/3, because minus 4/3 minus 3/3 is going to give us negative 7/3. And this equation is written in slope-intercept form through this point with the same slope. Now, any line that is perpendicular to the given line must have the slope, the reciprocal slope of this. The reciprocal of this is simply negative 3/2. And we can use the point slope form again to generate the equation. Now let's erase this. So we get y minus negative 1 is equal to negative 3/2 times x minus 2. And I'm going to write the point right here. Simplifying, we're going to get y plus 1 is equal to negative 3/2 x plus 6/2. Now, if we simplify further, we're going to get y is equal to negative 3/2x. 6/2 is just 3, so I'll just write 3. And then plus 1 on the other side will become minus 1. Simplifying further is going to give us this. And this equation is also in slope-intercept form. So that's it for today. Thank you so much for watching. If you have any questions or concerns, please don't hesitate to leave a comment in the comment section below. Please don't forget to subscribe, and we'll see you next time.